What did we just do?
Rock candy.
We made rock candy. How did we do it?
Sugar, sugar.
Yeah.
Melted sugar. Dipped the skirt.
First you put water and the chicken scoop.
First you were too crazy to put the whole packet inside.
Yeah. Guys, did we put the whole did we put the whole package of sugar inside?
Yes.
Yeah. And
then you said we have to take a scoop and put it inside the water and then do wallets on sugar.
And there they are, right?
Yeah.
So we're gonna leave them there. They're not gonna be done today. Well, they might be done afterwards. Yeah, next week.
Ow.
And what else did we say? Did we say that how much do we get more sugar mixed in when the water is cold, or more sugar mixed in when the water is hot? That's right. That's right. And what kind of molecules are we going to have here? Are they going to be arranged like crystals?
Yeah.
Yeah. It's good. It's called crystallization. It's going to look like crystals. What does a crystal look like? Yeah, like squares. It's very regular shapes. Yeah.
It's like a diamond
Very straight lines. Yeah.
Connected.
Exactly. Very straight lines, right? It looks like boxes all next to each other,
Like this.
right?
Here.
So we're gonna watch. You guys want to watch a little video showing it? Okay. So we're gonna watch a little video, okay? And you know what we're gonna do next? We're gonna do something cool with fire next. We're gonna show two matches stuck together because of an explosion that's so hot that it makes the matches stick together.
The fire seesaw.
Okay. Yeah, I do remember that. You remember that from last week? Yeah. Okay, first we're going to watch a video though. Everybody come here to the computer. We're going to watch a video explaining the crystals.
Which one? I'm getting scissors.
Here, you see how
But how?
see how it looks like it's looking at you?
Yeah.
So, do you guys want to make our own?
Yeah.
Okay. So we have over here some sheets and they have very careful instructions on them. Hallel and Aaron made one already, so they're going to be able to help you guys make your own, okay? You guys want to make your own dinosaurs that are 3D illusion? Yeah. You remember what an illusion is? No. An illusion is something that looks like something, but it's really not that. It looks like something that it's not.
It looks like it's not.
Avia, you want to make a dinosaur?
I do know how to go.
Sky, you're making it really well so far. That's really great. And Sarah Levana, do you want to show the camera? Oh, you're helping. Thank you, Sarah Levana. That's so nice. And this is the one that Sarah Levana made. And it looks awesome. Hold on, we did the ear weird. Take the ear out. I think we did the ear weird. I don't know.
I do know how.
That is cool. Sarah Levana, that is cool what you made. Well, I think we should walk around and help people.
How did they do that?
The teeth, I don't...
This thing. How did they fold it?
Oh, that's a fold. That's not a cut.
Daddy,
Wait until everyone's done.
We are trying to make things look like that dinosaur.
I'm cutting.
Oh, great job, Miriam.
Can you hold me?
How about you guys? Are you guys cutting very carefully?
Yeah.
Good job, Maya. The more the white that you get rid of, the better, okay? If there's still white there, it might not look as good. Okay? Oh, this is the one that's messed up? Okay. You guys are doing a great job. You have to basically color as...
I don't get how you do this.
We're going to create an explosion that's so hot that two things... They're going to stick together. And you know how we're going to know that they're going to stick together?
How?
Because one is going to lift up into the air and be stuck in the air. Okay? You guys ready? Okay, everybody watching? Aaron, you watching?
Yes.
Okay. We're gonna make them stick together from such high heat.
Nothing happened.
Nothing happened yet. Keep watching. Keep watching.
I'm watching. What's going on down? Oh, cool. It's starting to float.
It's floating in the air. Is that cool?
Yeah.
That magic is floating in the air. Now, how did that happen?
Because of the heat.
Because of the heat. There was so much heat. Where was there the most heat?
This.
In the middle, right? That's where there was the most heat, right?
Oh, it's like a person walking like this. It's like a slide that's fire.
It does look like a slide on fire, yeah.
A slide is the air on fire?
No, well, no, the air is not a good fuel for fire. But, shh, guys, shh. We're doing an experiment. Hallel, come here now. Look, what happened? Where was there the highest amount of heat, the most heat? In the middle, that's right. And that made the two tops stick together because there was so much.
It was an explosion.
It was like an explosion, right? Light this on fire and it's gonna make a lot of sparks, okay? And what should happen when you have fire? And you know what's making the sparks? Fire, right?
No, man.
It's gonna be fire. And what happens when you put fire in water? What happens when you put fire?
It burns out. There's no more fire.
That's right. That's exactly right. That's what's gonna happen. Except, you know what I did here? What did I cover it with?
Oh, it's tape.
Tape. Yeah, I covered it with tape. Oh, you're getting it, Iska. Thank you. I covered it with tape. That's right, Sarah. So what we're gonna do is we're gonna put it in water and we're gonna see if it burns. Hey, Maya, we're trying to do science. So, what's the problem? What does fire need in order to burn, Aaron?
I don't know.
Charcoal.
Well, charcoal is a good fuel, but what else does fire need in order to burn?
Oxygen.
Oxygen. Fire. This guy, you're gonna make people dizzy. Just
Sorry.
okay. Guys, please. Hello. I don't want you talking to Myra. Okay, come over here. So we're going to, but we're gonna put it under the water. Is there oxygen under the water? No. So how is it gonna burn?
Because the sun.
That's a good guess. It actually doesn't have to do with the sun. Oxygen is in the air around us. There's no oxygen inside of this glass. Yeah.
Did you ventilate the room?
There's no oxygen in this glass. So if we put this, when it's burning inside of the glass, where's it going to get the oxygen from?
Around.
That's a good guess, but there's no oxygen inside of the glass.
Should I answer?
From here, that's actually the right answer. On here, we don't see it, but there's oxygen in here. There's something called an oxidizer, and that makes oxygen available for it to burn. So we're going to light it on fire. You guys ready to see the sparkler?
Yes.
Okay.
I'm trying to open the
It's
window.
Sparkler.
I'm trying to open the window.
Pop.
See that?
Fast,
it's
falling.
Is that cool? Now we're going to put it in the water. And it's still burning. Isn't that crazy?
Yeah.
You know why it's still burning?
Not burning anymore.
Not burning anymore.
Sorry.
That smelled bad?
La clase de segway doesn't stop.
It
Yummy.
does smell bad.
Smells yummy.
Maybe we could burn from the other side too. Well, whatever. We saw that it was burning even while it was underwater. Isn't that cool?
Ooh, amazing.
This one taped the whole thing.
It did tape the whole thing. Yeah, it does smell awful. Okay. So why did that happen? Guys, why did that happen?
Because it was in something cold.
No, it actually doesn't have much to do with cold or anything to do with being cold. You know what it's about? It's because it didn't have any oxygen around it, but it does have oxygen in it. So when it goes under the water, the oxidizer, there's something around near this sparkler, all this metal in here. There's something that makes oxygen. It makes oxygen. Just like there's oxygen in the air, it makes oxygen inside of here. Isn't that cool? Oxygen is what we breathe and also what a fire needs in order to be burning.
You burned part of the table because part of the sparkler fell.
Where did it fall?
Over there, next to the...
Oh, that's okay.
The table will be okay.
Yeah, the table's okay. But thank you. Should we try it one more time?
Yes. And now we do from the beginning. Be careful.
Be careful.
Whoa!
Dip it.
Dip it.
It's underwater. It's still burning even though it's underwater. Isn't that crazy? And hold on, how do we know there was oxygen? Did you see the bubbles coming out?
Yep.
That was oxygen bubbles. The truth is any gas can make bubbles underwater. But those are oxygen bubbles. Or
No.
Never drink that
some
water.
of it was oxygen and some of it was probably carbon dioxide.
Hi, Ba.
What are we going to do now, everybody? The first part of this experiment is to say the word Leidenfrost. Everybody say Leidenfrost.
Lead and hot.
Okay, cool. Good job. Okay, well, what we have here on the stove, we have fire under a pan. Now, we also have some water. What happens when you pour water onto a pan?
Nothing.
Well,
Hey, we can see
I'm gonna take it off. We see something. That's exactly what I wanted to show you.
sugar.
It looks exactly like sugar, right?
What is it?
Hallel. Guys, you looking?
Yeah.
What'll happen if it's not that hot? What'll happen if the pan is hot
Nothing.
and the water and you pour water?
Nothing.
Exactly, that's evaporation, right? It'll evaporate. But that's not what's happening now. Well, it is eventually evaporating. But you know what's really cool here?
Hey,
You know what's very cool? We're seeing here. Here, let's push this back onto the flame. We're seeing here beads of water.
Yep.
Beads of water. Isn't that weird?
if we touch them?
Actually, so that's a very good question. If you touch the water is cooler than 100 degrees Celsius. You know how I know that? Because if it was 100 degrees Celsius, you know what it would have turned into? A gas. What's water gas?
Did you ever touch it?
Well, actually, I'm going to because my fingers are already messed up from the fire before. So I'm gonna try this. I'm gonna be the guinea pig. But what do we call water that's a gas?
Smoke.
Yeah, steam. Steam. Yeah.
Smoke.
So we're gonna do this now, and you're gonna watch.
Come on, touch it.
Look, it turned into beads, right?
Are we gonna see?
Now, how did that happen? Whoa! Do you see that? Now, eventually it burns off. Eventually, it burns off. But
They're the big ones that's collecting all of them.
look at that! Isn't that crazy? It doesn't burn right away. Look at that guy over there.
Touch that guy.
Now all that did disappear. But look at that. All right. I'm gonna try to touch. All right. Okay, hold the camera. Don't try this. Don't try this at home, okay?
But this is your home.
Yeah, you guys don't try this at home. Okay, I'm gonna dip my finger into water, and then I think that'll cause. So I'll explain this experiment in a minute to everybody. Right now, I think I cooled it down. So what we want to do? What's going on here? You know what's happening? There's a little. When a drop of water touches the bottom of the pan, you know what happens? Instead of it immediately turning into smoke, the bottom of it turns into steam. Right?
Yeah.
Maya, you listening? The bottom of it turns into steam. When the bottom turns into steam, you know what that does? That keeps the top of it from touching the bottom of the pan. So it's like it's floating. Has anybody ever played air hockey?
Yeah.
No.
Air hockey is when you have a puck that floats
Oh yeah.
on top of the board.
Touch it.
Well, now it's not happening anymore.
There, quickly.
Oh, I just touched the pan with my finger. I just touched the pan with my finger.
Right?
No. I mean, it was hot. I could feel that it was hot, but my finger was fine.
Go do it one more time.
No.
Good. I got it.
Please do it.
You know why? It under my finger was a little bit of smoke. Was a little bit of steam.
So quickly.
And the steam was very hot, but it kept the rest of my finger from touching the very hot pot.
Chris, touch one of them.
No,
Why?
I don't want to encourage people to be touching pans.
Yeah, it's probably not.
Isn't that cool though? It looks like beads, right?
Yeah.
Is that crazy?
More.
No.
Okay.
Let's
I'm gonna do
go.
one more, okay?
Wait.
You're gonna video it closer?
Okay. I need to make videos go so. Come on.
Okay.
Look.
Come on, look.
Nope, that time it didn't
Sensei.
work. That time it didn't work. Oops, you okay? Okay. You have to wait for the pot to get super hot. If the pot is about 100 degrees Celsius, you know what will happen to the water?
Well,
It'll immediately evaporate. Well, not immediately, but it'll start evaporating when it touches the pan.
yeah.
But when it becomes 110 degrees, it'll burn a little bit faster. 120 degrees will burn a little faster. It'll evaporate a little bit faster when you raise the temperature until you reach something called the Leidenfrost point.
Come on.
When you reach the Leidenfrost point, nope, that didn't happen. Oh,
There.
did you see the beads? I think we're getting like a coating of some sort, maybe from the minerals in the water.
Yeah,
That's
what you're getting is
interfering.
Yeah, for evaporation now. All that.
Yeah, it's interfering with the effect. But we still have some places here.
Oh yeah, I got
Yeah,
it.
it's only
Got
happening
it.
in certain
Got it.
places.
Got it.
Isn't that cool? Okay, what's wrong with the rest? Hope for the best. Okay.
I got it.
Okay.
Here, take it.
Thank you. Okay, what are we making?
We need a teensy weensy water.
Okay, what are we making?
Real tiny.
Plants.
Plants.
We're planting beans for a beanstalk, right?
No.
Are we gonna have a giant climbing up the beanstalk?
Yeah.
Okay, maybe. Depends on how big the beanstalk grows, right? What does a plant need in order to grow?
Water and sun.
Water and sun
And air.
and air and the beans, obviously.
Soil.
And soil. Well, actually, so the soil is going to be the cotton, and we're hoping. You know what we're hoping? We're hoping that the cotton will give the beans a place for roots to grow. Shh, guys, Marianne, please stop talking. So we're gonna put these outside. We're gonna put them on the ledge, I guess, and we're gonna let them grow.
We can put one from this.
Yeah. Okay, that's a great idea, Aaron. Yeah. Maya and Halo, you guys ready to put water in? Did you put your beans inside? I think the beans being on top might be best in my experience because the sun needs to get to it. I don't know if you want to bury them. But- Okay, but we're scientists. What do scientists?
Hold on.
Great. What do scientists do? What do
They figure out stuff.
they figure out stuff? Is exactly right. So we don't know.
Like say the sense.
So we don't know what's right yet, and we're going to experiment in order to figure out stuff, right? We're going to figure out which is best. What?
Why do you think that they need sun? Usually you plant seeds under the dirt. You don't see the sun.
Oh, that's a very good point, Mommy. Mommy is a good scientist. Usually you plant seeds under the dirt. So the leaves are really what needs sun. So that's a good point. I guess you don't need sun. Okay. But we need to put in the sun for when the leaves come out. Thank you, Mommy. Okay. So that's actually also what scientists do. They use their reason to try to figure out what they think will happen, and then they test it. So we're going to have some beans that are above, on top, that are closer to the sun, see the sun better.
Put my beans here to make a mouth.
Cool. Okay, that's interesting.
I can make it.
Okay, great.
This.
Is everybody watering their plants?
Wait a minute.
You need water. You need water to touch the cotton. Water has to be on the cotton that's touching the.
I'm putting three in the bottom and then I'm putting cotton and then I'm putting three in the top.
That's a great experiment, Iska. And then when we come back for science camp next week, we're gonna see how they grew. Okay?
I'm just gonna fill I went to get the pie house.
You can do that, sure. Okay. Okay. You could take it home, or you could leave it here, and then they could all grow here, and whatever you think. You know what? If you take it home, just try to remember to bring it back next week so we could show it. You could show it to all your friends here. Okay?
Daddy,
There's good soil.
are we going to do
What
this
are
one?
the
Nope.
balloons for? What are the balloons for?
The balloons are for an experiment a different week.
Birthday party.
For the